You pick up a stone no bigger than your palm. Its edge is sharp, but the stone is not the tool. Not yet. You press it into a wooden handle, you bind it tight, then you push the point into hard wood. Suddenly, your hand has more reach, more force, more control. It sounds simple. But 160,000 years ago, that idea changed everything. For decades, archaeologists told a familiar story. Early humans in Africa and Europe were inventive. They shaped elegant hand axes. They prepared stone cores. They built tools from several materials. East Asia looked different. Its stone tools often appeared larger, rougher, more conservative. That contrast became so influential that it was drawn as a line across a map, the Movius Line, a label for an old archaeological divide. West of the line, researchers expected complex hand axes. East of it, they expected simpler chopping tools. The line was never a wall. No ancient human could see it. But for generations, it shaped how scientists interpreted the past. Then, archaeologists dug into a hillside in central China. The site was called Zhigo. It lies in the Donjiangkou Reservoir region. There, beneath layers of sediment, thousands of stone artifacts waited. Some were tiny, some were carefully retouched, and some carried a feature nobody expected to find so early in East Asia. A tang, a narrow stone projection designed to fit into something else. Probably wood, possibly reed. The stone had not been made to sit alone in the hand. It had been made to become part of a larger machine, a composite tool. That means one tool built from multiple materials. Stone plus wood, edge plus handle. A small idea with enormous consequences. In 2026, Jianping Yue, Guoding Song, Michael Petriglia, and their colleagues published the Zhigo evidence in Nature Communications. The artifacts came from layers dated between roughly 160,000 and 72,000 years ago. The team examined more than 2,600 stone pieces. Many were small flakes. Some measured less than 50 millimeters, about the width of 2 fingers. Small did not mean simple. The toolmakers selected raw material. They struck flakes from prepared cores. They shaped edges. They created points and borers. Then, in several cases, they formed bases that could be inserted into handles. Each step depended on the one before it. That matters. A handheld stone can be useful immediately. You find it. You strike it. You cut. A hafted tool demands something more. Hafting means attaching a stone working edge to a handle or shaft. First, you must imagine the finished object. Then you must make separate parts. The stone must fit the handle. The handle must survive pressure. The binding must hold. The angle must work. And the entire object must solve a problem better than the stone alone. This is planning. Not planning for next winter. Planning across a sequence of actions. A mistake at the beginning can ruin the final tool. So why build one? Leverage. A handle changes how force moves through your body. Your wrist no longer absorbs everything. Your arm pushed from farther away. A narrow stone point can rotate, scrape, or bore with greater control. Michael Petraglia described this as a way to improve performance. The handle provided more force for actions such as boring. Microscopic traces on the Zhigo edges support that idea. The tools appear to have worked plant material. Probably wood or reeds. Picture the scene. You are standing near a river system in central China. The climate is unstable. Cold phases come. Warmer phases return. Forests expand. Then grasslands spread. The animals move with the vegetation. Water shifts across the landscape. Your survival depends on adjusting faster than the environment changes. Stone is everywhere. But food is not. Shelter is not. A carrying basket is not. A digging stick is not. A trap is not. A spear shaft is not. Many of the things you need begin with plants. Wood must be cut. Reeds must be pierced. Fibers must be split. Handles must be shaped. A small stone borer inside a wooden grip could make those jobs easier. It could help create objects that almost never survive archaeologically. Wood rots. Fiber disappears. Bindings decay. Stone remains. That creates a strange problem. The most important part of an ancient technology may be the part that vanished. You find the stone, but not the handle. You see one fragment, then you mistake it for the entire invention. The Zhigo team had to reconstruct the missing half. They studied the shapes. They examined the bases. They compared wear patterns. They looked for traces created by repeated movement. The evidence suggested that some stones had been mounted, not merely held, not accidentally wedged, designed to work as components. This is the first big surprise. The invention was not a new kind of rock. It was a new relationship between materials. Stone became more useful because it was combined with something softer. The hard part depended on the fragile part, and the fragile part vanished. But there was an even bigger mystery. Who made these tools? At 160,000 years ago, East Asia was not occupied by one clearly defined human population. Several possibilities exist. Early Homo sapiens may have reached parts of the region. Denisovans were present somewhere in Asia. Other fossils have been assigned names such as Homo longi and Homo juluensis. Those labels describe branches that researchers are still trying to connect. Ben Marwick of the University of Washington, a co-author of the Zhigo study, emphasized the uncertainty. There is no confirmed fossil maker at the site. No DNA has identified the hands behind the tools. That absence is important, because the old story often treated technology like a species badge. Find one style of tool. Assign one kind of human, find a different style. Assume a different mind. But tools do not obey neat family trees. Ideas can appear independently. They can spread between groups. They can be copied, modified, abandoned, then reinvented. The Zhigo tools do not prove six. They expose the weakness of as species was smartest. The real question is harder. How many different kinds of humans were capable of complex planning? For much of the 20th century, East Asian stone industries were often described as static. The word sounds neutral. It was not. Static implied little change, little experimentation, perhaps even limited cognitive ability. The Movius Line reinforced that assumption. Hallam Movius proposed the divide in the 1940s. Acheulean hand axes seemed common across Africa and Western Eurasia. They appeared scarce across much of East Asia. So the absence of one famous tool became evidence for a broader absence of innovation. But a hand axe is only one solution. It is not a universal intelligence test. A population living among bamboo, wood, reeds, and changing river environments invent technologies that leave different traces. They might use understanding inserts. They might tend smaller stone handles. They might build tools that disappear after death. Anne Ford of the University of Otago praised the Zhigo work for exactly this reason. It pushes archaeology away from describing Asian technologies as simple core and flake industries. Core and flake means a stone core struck to remove sharp pieces. The method can look basic, but the final system may not be. A tiny flake can belong to a complicated tool. A crude-looking point can sit inside a carefully shaped shaft. The sophistication may exist in the assembly, not in the stone alone. That leads to the counterintuitive twist. The Zhigo discovery is not really about an invention appearing too early. It is about archaeologists recognizing it too late. The ancient tool makers were not waiting to become creative. The evidence was waiting to be read differently. For years, researchers searched for complexity in objects that resembled European examples. Large hand axes, symmetrical forms, familiar categories. Zhigo suggests another possibility. Human ingenuity does not always produce the same shape. It responds to local problems, local materials, local traditions. The makers at Zhigo did not need to copy Western Eurasia to prove they could plan. They made tools suited to their own world. That world lasted through roughly 90,000 years of environmental change. The occupation layers span enormous time. Different generations may have returned. Different populations may have used the landscape. Yet the technology reveals repeated flexibility, not one frozen tradition, a toolbox of strategies, prepared cores, retouched flakes, small implements, possible hafted borers. Each one represents a decision. What material should you use? How should you shape it? What job must it perform? How much time is worth investing? Those questions still live inside every tool around you. Your kitchen knife is a composite tool. So is a hammer, a screwdriver, a toothbrush. A stone point fixed into wood belongs to the same basic logic. Separate materials do different jobs. The handle protects your hand. The working edge meets the world. The invention feels obvious because you inherited it, but obvious ideas are often invisible after they become normal. You do not think about the boundary between a metal blade and a plastic grip. You experience one object. That mental fusion began deep in prehistory, long before factories, long before writing, long before anyone recorded the inventor's name, and that may be the quietest part of the discovery. The person who first tried this left no portrait, no grave inscription, no story. Maybe the first attempt failed. The stone slipped, the binding broke, the handle split. Then someone adjusted the angle, changed the cord, cut a better groove. Innovation probably did not arrive as a flash of genius. It arrived through irritation, through repetition, through hands noticing what almost worked. You know that feeling. A tool is uncomfortable. A task takes too long. Something keeps breaking. So you change one small part. Then the whole system improves. That instinct is older than your species' written memory. It may not belong to Homo sapiens alone. It may have been shared across several human lineages, different faces, different bodies, the same ability to imagine an object that did not yet exist. The discovery also changes how you picture movement. A hafted tool is not only stronger, it is portable knowledge. Once you understand the design, you can rebuild it somewhere else. You can carry the stone insert. You can replace the wooden handle. You can teach another person where to cut the groove. That makes technology social. A tool can preserve an idea outside the brain. One person experiments, another watches. A child copies the motion. A group keeps the successful version. Over generations, the object becomes a tradition. No written instructions are required. The handle itself becomes the lesson. This may explain why apparently small innovations matter so much. They connect memory to material. They let one generation begin where the last one stopped. At Zhigo, the missing handles cannot show that teaching directly. But the repeated manufacturing steps suggest shared knowledge. People knew what shape they wanted. They knew how the parts should meet. They were not merely smashing rocks until something sharp appeared. They were following a plan. And every plan carried a history. You pick up a stone no bigger than your palm. But the stone is not the tool. The tool begins when you imagine what the stone could become.